Hi guys, it's Ashraf from WiZ.edu, and today we're going to be going through some easy examples with regards to type 2 questions, which are equations with restrictions. So for the first example, we are told that 17 sine beta equals 15, and beta is an element of 0 and 90 degrees, and we are asked to determine the value with the aid of a diagram, cos beta, as well as sine beta minus cos beta. So step one is to get the trig function or trig equation into the form trig function equals number. So we are given 17 sine beta equals 15. Now we want to isolate sine beta on the left-hand side. So we'll do this by dividing the entire equation by 17, and that gives us sine beta equals 15 over 17. Now, step two is going to be to determine which quadrant we are working in by looking at the restriction we are given. So we are told that beta is an element of between 0 and 90 degrees. Now, 0 degrees is over here, 90 degrees is over there. So we know that any angle between 0 and 90 must be within the first quadrant. And in the first quadrant, we know that x is positive and y is positive. Because of the cast rule, we know that everything is positive in the first quadrant. So our answer for cos beta is definitely going to be positive. So step two is to put our definition of sine on the right-hand side, which in this case is y over r, and extract our variables, and then use Pythagoras to solve for the missing variable. So from this, we can infer that y is equal to 15 and r is equal to 17. Now we can go ahead and use Pythagoras to solve for x, because we know that x squared plus y squared equals r squared. Our reason is Pythagoras, right? So we know that x squared must be equal to r squared minus y squared if we rearrange that, and we can substitute our variables in, r being 17 and y being 15. 17 squared is 289. 15 squared is 225. If we subtract those, we'll get 64. And if we square root both sides to get rid of that exponent, we'll get x being equal to plus or minus 8. Because remember, when you square root, you can get a positive or negative. And now for our next step, we have to choose, are we going to use a positive or a negative? Well, we said we're looking at the first quadrant, so x and y would both be positive. So our answer must be positive 8, and this must be positive 15 over here. And our r is always positive because it's a length, and length is a scalar, so that's always positive. So now, using our three variables, we can go ahead and solve the question. So for beta, we know that x is equal to positive 8, y is equal to positive 15, and r is equal to positive 17. So to solve for cos beta, all we have to do is put in our definition for cos, which is x over r, and that gives us positive 8 over positive 17 if we substitute in. So our final answer is 8 over 17. Now for our next bit, which is to find the value of sine beta minus cos beta, it's slightly more complicated, but not really. So all we have to do is put in our definition for sine and cos again. So sine beta minus cos beta would be equal to, definition of sine is y over r. And I'm not going to put in the definition of cos because we've already found the value for cos beta in the first bit of the question. So I'll just keep the minus there and substitute in 8 over 17 because we've already done the hard work. It would be pointless to do it twice. So now we know that y is positive 15, r is positive 17. We can merely substitute that in. We have 15 over 17 minus 8 over 17. Our denominators are the same, so we can subtract our numerators, and we get our final answer to be positive 7 over 17. So we've answered the first question. So let's get on to the next question. We are told that we need to determine the value of 4 cos A plus 2 sine A if 3 times 1 over tan A equals 4. And we are told that A is an element of 180 degrees to 360 degrees. So our first step is to always get in the form of trig function equals number. And in this case, you can see we are definitely not in the form trig function equals number because we have a 3 on the left-hand side and we have a fraction. So we'll divide the entire equation by 3 to take the 3 over to the right-hand side, and that will give us 1 over tan A equals 4 over 3. Now, we have 1 over tan A on the left-hand side. So how do we get rid of that? Well, we can basically invert both sides, so that would then become tan A over 1 equals 3 over 4. So tan A is equal to 3 over 4. Now, step 2, we'll take a look at our restriction. In this case, we are told that A is an element of 180 to 360 degrees. So if we had to look at that on our Cartesian, we have 0, 90, 180, 270, and 360. So A could be anywhere between 180 and 360. That's what we're told. So A could either be in the third or fourth quadrants. And we'll see a little bit later how this helps us. Okay? So we can extract our variables here by putting our definition in for tan, which is y over x. So we get y to be 3 and x to be 4. Now our next step is going to be to solve for the missing variable, in this case r, using Pythagoras. So we know r squared equals x squared plus y squared. Reason is Pythagoras. So r squared will be 4 squared plus 3 squared, and you can see this is a Pythagorean triple. That's going to be 16 plus 9, which is 25. And if we root both sides, our answer should be plus 5. In this case, we won't have a plus or minus because we know that r is always positive because it's a length. Now for our next step, we'll take a look and see which sign are we assigning to each variable. So what's going to be positive and what's going to be negative. So we know that A lies within the third or the fourth quadrant. In the third quadrant, x is negative and y is negative. In the fourth quadrant, x is positive and y is negative. So how do we know what sign we're going to be assigning to x and y? Well, earlier on in the first video in the method, I said when you look at the trig function, you also have to look on the sign on the right-hand side in conjunction with your restriction. So we know that our quadrants that A might lie in are quadrants 3 or 4. And we also know that tan A is positive because tan A is equal to positive 3 over 4. And now from the cast rule, we know that tan is positive in quadrants 1 and 3. So the quadrant we must be working in for tan A to give us a positive answer must be quadrant 3. It can't be quadrant 1 because we're told that A is between 180 and 360. So in quadrant 3, we know x is negative and y is negative. So we'll put a negative by our 3 here and a negative by our 4 there. So negative 3 over negative 4 still gives you the positive 3 over 4 that we have for tan A. So let's go ahead and write our variables for A over here. So we know that x is negative 4, y is negative 3, and r is positive 5. So we can substitute these into the definitions of the trig ratios to solve our question. So our definition for cos is x over r. Our definition for sine is y over r. And now we can just substitute our variables in. So that would be 4 times negative 4 over 5 plus 2 times negative 3 over 5, right? So we can simplify this to be negative 16 over 5 minus 6 over 5, which gives us a final answer of minus 22 over 5. And that would be our final answer. If you wanted, you could write this as a mixed fraction as negative 4 and 2 over 5. But negative 22 over 5 would be just fine. For question 3, we are told that tan beta equals negative half, and beta is an element of 90, 180. Determine with the aid of a diagram sine squared beta and cos squared beta minus 1. So how would we go about doing this question? Well, we are already in the form of trig function equals number, because on the left-hand side, we just have our tan beta. So we can immediately go to step 2, which would be to look at our restriction and find out which quadrant we're working with. So we're told that beta is between 90 and 180. So we must be looking at quadrant 2. And in quadrant 2, we know that x is negative and y is positive. So now we can go over to tan beta, put in our definition, which is y over x, and extract our variables. But the question you're going to be asking yourself is, where is this negative going to go? Is my negative associated with my numerator or my denominator? Because am I going to say that y is negative 1 or y is positive 1? Or x is negative 2 or positive 2? Well, we can look at our diagram here, and we know that tan in the second quadrant is negative, so we do expect a negative to be there. And we know that x would be negative and y would be positive. So when we extract our variables here, we'll keep y to be positive 1, and we'll give the negative to the x and make that negative 2. So now we can go ahead and use Pythagoras to find r. We know r squared equals x squared plus y squared, and that's reason is Pythagoras, right? So we know that x is negative 2 and y is 1. So that gives us 4 plus 1, which is 5. So we can square root both sides, and we get r to be positive root 5. Because r is a radius and a length, so it's always positive. So now we've found our 3 variables. So we know that for beta, x in this case would be negative 2, y would be positive 1, and r is positive root 5. So we can use this to solve the question. Now we can say that sine squared beta is equal to, definition of sine is y over r, and in this case, it's all squared, right? So you can substitute in y to be positive 1, r to be root 5, square that, and we get an answer of 1 over 5. Now the next question is a bit interesting, because we are asked to find the value of cos squared beta minus 1. Now, if you weren't really paying attention, or if you weren't awake, you would have gone and done this. You would have said cos squared beta minus 1 equals, you would have substituted your trig ratio in, and you would have gotten minus 2 over root 5 all squared minus 1, which is 4 over 5 minus 1, which would then give you negative 1 over 5. However, if you were awake, you would have recognized the relationship between cos squared beta minus 1 and sine squared beta. From the Pythagorean identity, we know that sine squared beta plus cos squared beta equals 1. So if we rearrange this to make sine squared the subject of the formula, we get 1 minus cos squared beta. Now that doesn't exactly look like the cos squared beta minus 1 we are asked to solve for in the question, because we have cos in the front here and we have a negative 1 at the end. But what if we multiply this entire equation by a negative? We get negative sine squared beta being equal to cos squared beta, that would now be positive, minus 1 over here, which is the same. So in our first question, we found the value of sine squared beta. So if we just multiply that by a negative, we'd have our answer for cos squared beta minus 1. So you could have just taken this first answer you got over here, multiplied it by -1, and got -1/5, which is the same as your answer over here. But it just required you to recognize the Pythagorean identity in the question. So let's go on to the next question. Example 4. We are asked to find the value of 10 over cos theta plus 13 sine theta if 5 tan theta plus 12 is equal to 0, and we are told that theta lies between 180 and 360. Step 1, get into the form trig function equals number. So we have 5 tan theta plus 12 equals 0. Step 1, we'll take the 12 across. So that would be then 5 tan theta equals -12. We can divide the entire equation by 5 to move the 5 across, and that becomes -12/5. Step 2, we'll take a look at what quadrants we are working with by looking at our restriction. So we know that theta is between 180 and 360 degrees. So that encompasses quadrants 3 and 4. And we know that in quadrant 3, x is negative and y is negative. In quadrant 4, x is positive and y is negative. So now when we're extracting our variables from tan theta, because we know that tan is equal to y over x, do we assign the negative to the y or the x? Well, we know that from our method, we have to look at our restriction in conjunction with the sign here we have on the right-hand side. So we know that tan is negative because tan equals -12/5. And from our cast rule, we know that if tan is positive in quadrants 1 and 3, it must be negative in quadrant 2 and 4. So for tan to be negative, we must be working with quadrant 4, where x is positive and y is negative. So from there, we have deduced where to assign our negative. So now we'll say that y is equal to -12 because we're working in quadrant 4, and x is going to give us +5, right? So now we can go ahead and use Pythagoras to solve for x. So r squared equals x squared plus y squared. Reason, Pythagoras. So we know that r squared equals 5 squared plus -12 all squared. Now we know that r squared is going to be 25 plus 144. So r squared is going to give us 169. So r equals √169, which is 13. So we have r to be 13 and it's going to be positive. So now we have for theta, our three variables. We know x, y, and r. We know that x is +5, y is -12, and we've just found r, which is +13. So we can go ahead and substitute that into the question and into our ratios to solve. So 10 over, definition of cos is x over r, and sine is y over r, right? So that would equal 10 over, substitute our value for x, 5/13, plus 13 times, y is -12 in this case, over 13. So you can already see we can do some cancelling here. That 13 can cancel with that 13 there. And then we are left with 10 multiplied by 13/5 minus 12. Now that 10 can then cancel with that 5 to leave us with 2. So we have 2 times 13 minus 12, which is 26 minus 12, which is going to give us an answer of 14. So all that is equal to 14. So for example 5, we are asked to find the value of 1 over cos squared theta plus tan squared theta if 2 over sine theta equals 5 and theta is between 90 degrees and 360 degrees. So step 1 is going to be to get into the form of trig function equals number. So we can basically divide the entire equation by 2 to take out 2 across. So that would become 1 over sine theta equals 5 over 2. Now we can invert both sides. So that would give us sine theta equals 2 over 5. So now we're in the form of trig function equals number. Now we'll look at our restriction to find out which quadrants we could possibly be working with. And we know that theta equals, well, theta is between 90 and 360. So that encompasses this whole area over here, 90 to 360. So that's quadrants 2, 3, and 4. However, if we wanted to isolate exactly which quadrant we are working with, we could look at the sign that we have on the right-hand side over here. We know sine is equal to positive 2 over 5. And we know that sine is only positive in quadrant 1 and 2 because of the cast rule. So we must be working with quadrant 2. And in quadrant 2, we know that x is negative and y is positive. So we'll just keep that aside for when we solve for x, which we'll now do using Pythagoras, because we know that sine theta equals y over r. So our y is 2 and our r is 5. So now we can use Pythagoras here. We know r squared equals x squared plus y squared. Reason is Pythagoras, right? So now we can substitute for r in there. 5 squared is going to equal x squared plus 2 squared. We can rearrange that and we get 25 minus 4. So x squared is 21. If we square root both sides to get rid of that exponent, we get x to being root 21. But remember, when you square rooting, your answer could be positive or negative. So is our answer positive root 21 or negative root 21? Well, we've determined that we're working with the second quadrant, and in the second quadrant, x is negative. So our answer is going to be x equals negative root 21. So we have our three variables for theta, x, y, and r, and we can use these to solve the question. So we know that for theta, x is negative root 21, y in this case is going to be positive 2, and r we found to be positive 5. So we can put in our definitions here and substitute in. We know the definition of cos is x over r, and tan is y over x. And in this case, both of these are squared. So we can substitute in here. That's going to be negative root 21 over r is 5 squared plus y is positive 2, x is negative root 21, all of that squared. So let's go ahead and simplify. That's 1 over positive 21 over 25 plus 4 over positive 21. We can simplify and say that's going to be 25 over 21 plus 4 over 21. And that's our final answer is going to be 29 over 21. And if you wanted to, you could write that as a mixed fraction, which would be 1 and 8 over 21. And that concludes our easy examples. Thanks for watching.